Good afternoon or good morning, depending on where you're joining us from. And thank you for joining us for today's webinar entitled Leveraging Hyperconvergence for Database and Tier 1 Enterprise Applications. We're very happy today to have DataCore on the line to talk about parallel I/O and hyperconvergence and a number of other things that they're doing that are really cool and that can help you improve your application performance, particularly for some of those beefier applications that you may want to move to hyperconverged infrastructure. I'm joined today by Sushant Rowe, who is the Senior Director of Product and Solutions Marketing for DataCore. Sushant, thank you for being here.
My pleasure.
Before we get started, we're going to have just a few things to go over. Number one, we have a number of handouts for you today. If you look in the GoToWebinar control panel, you'll see that there is a handouts option that says 5 of 5. There are 5 handouts for you to review. They're really good stuff. One of them is a white paper that Actual Tech Media did for DataCore, and we have a case study for you to review. We also have a DataCore data sheet about the solution they're going to be discussing today, the results of a survey that DataCore has done for 6 years in a row around the world of storage and hyperconverged infrastructure, and lots of other good stuff. So make sure you take a look at that handouts area to download all that great content. Most importantly, we want to make sure you get everything that you can possibly get out of today's event. And that means that we want you to ask questions. In the GoToWebinar control panel, you're going to see a Q&A or a questions area. We want you to ask lots of questions. In fact, we'll be taking questions throughout the event and at the end of the event. If you have a question about anything at all, life in general, but specifically around what we're talking about today, please make sure to ask that in the Q&A area and we will get to your question. Throughout today's event, we're also going to be asking you a number of poll questions. We like to understand where our audience is coming from with regard to the topic at hand. We like to know where you stand, what your thoughts are, what your initiatives are to help us better tailor our content and to help companies like DataCore make sure that they understand where you're coming from as well. So we would ask you to answer the poll questions if you're able. They will come up at various points throughout the event. And at the end, of course, we have a great prize, a $300 Amazon gift card we'll be giving away to one lucky winner. As for an agenda today, we'll be starting out with a discussion around the background of hyperconverged infrastructure and address some of the concerns people have around potential performance challenges in the world of hyperconvergence. And we're going to talk about the one critical metric that you have to understand when it comes to hyperconverged infrastructure and really any part of your data center in general. It's what I think of as the golden metric, really, that really all other metrics are judged by. I'll also share with you some high-level DataCore performance results of what they can do when it comes to improving the overall performance of a hyperconverged solution and give you the beginnings of a discussion around the parallel I/O advantage that DataCore brings to bear. DataCore will then talk about a case study that they've done with the Emergency Communications of Southern Oregon organization that has leveraged DataCore and the excellent and actually the incredible results that that organization has achieved. You're going to hear a real live customer case study on today's webinar. And they're going to talk to you about how their hyperconverged virtual SAN capabilities can help bring to bear a solution that will support even the beefiest of databases and the most intense of tier 1 applications. And at the end, we'll do some more Q&A and we'll do a prize giveaway. Before we get started, though, we're going to ask our first poll question. And the poll question that we're going to ask is, what use cases are you considering for hyperconverged infrastructure? And this is a multi-select question. And Sushant, when you talk to customers, each one of these things, what are some of the things that they are really trying to achieve when it comes to hyperconverged infrastructure?
It's a great question. I think, when you look at something like remote sites, I think a lot of people are saying, how do I make sure I can shrink the amount of infrastructure, yet make it highly available, right? Oftentimes at remote sites, people just don't have IT personnel there. If they do, it's more desktop, but not, for example, data center type folks. So they really need to make sure that if they have a manufacturing site, for example, that the equipment there can pretty much just run, but usually they're space constrained, so they want to make it smaller. So those are the kinds of things that I see reasons why people are looking at something like remote sites. VDI, I think, is pretty straightforward. People are looking for kind of a scale-out architecture and say, look, I just need to know when I have 50 people, how many nodes do I need, right? And then if I keep on adding people, how do I scale out from there? I think those are some of the things that we've seen in terms of the reasons why people are looking at hyperconverged for some of these use cases.
We have some really good results for this, and I'm going to share those with the audience right now. And it actually speaks to how far we've come with hyperconverged infrastructure. You know, early on, it was really VDI was the original use case, right, around hyperconverged. And we're seeing a lot of organizations now take a more infrastructure consolidation approach, almost like we did with the early days of virtualization, right?
Exactly right.
And so this is something where we definitely see a lot of interest there around this general purpose. And I think the idea of moving to general purpose computing with hyperconverged infrastructure is a powerful one. And the results here definitely bear that out. And let's get started with the rest of our presentation. So we talked a little bit about this, but why would you even consider hyperconverged infrastructure? Well, first of all, let's take a look at some of the traditional ways that we've run infrastructure. So here we have servers with their own management console. We have some kind of a storage fabric, whether that's Ethernet based or whether that's fiber channel based, with another place to manage equipment. And then we have storage of some kind, and we have another place to manage equipment. Well, what people have said is that there's got to be a better way. They need to find a way that they can simplify what's really becoming a sprawling mess in a lot of ways to something that's simpler. And what we've seen is the emergence of hyperconverged infrastructure over the last few years as an incredibly powerful way for organizations to sort of rein in this madness. And what we see here is we're going to combine everything you see up above. We're going to get rid of the storage fabric because we don't need it anymore. We're going to take the storage and we're going to put it inside the server nodes, and then we're going to manage it all with a single console. And as we need more, we simply add more nodes, and we still keep the same console access to manage it all that we had when we had just 3 nodes or 2 nodes or whatever the case may be. So we're looking for ways we can simplify the environment. This is one of the key reasons we've seen organizations moving to hyperconvergence, and it really revolves around operational efficiency, which also ultimately translates to cost. And we'll talk more about that shortly. So when we started talking about those early use cases, you know, we mentioned before that virtual desktop infrastructure, or VDI, was one of those sort of primordial use cases when it came to hyperconverged infrastructure, and that was what people were making their fortunes on. And as Sushant alluded to, one of the beautiful things about hyperconverged infrastructure, especially with VDI, is the way you can scale it. So in the example you see on your screen right now, we've got 2 nodes with, it's a very simple example. That is 8 virtual machines on each one, 8 desktops. As you have a need for more desktops, you know exactly what the step size is. You know, if I want to add 8 more desktops, I add another node. Now, in the real world, you're going to support way more than 8 desktops per node. But for illustrative purposes, you can see that this is a very linearly scalable application that's very, very well suited for hyperconverged infrastructure. And we also saw a lot of what I like to call the low-hanging fruit. A lot of those very easy to aggregate applications move to hyperconverged. Sort of like we did in the early days of virtualization, like I said before. You know, early on, you looked at some of those applications and said, why am I wasting an entire server on this? And now it's, why am I wasting management cycles managing this thing on its own? We can move it into its own, into a new paradigm where we can make it more easily managed. We don't have to worry about separate storage for it and all that stuff. Now, some of these early applications were, you know, relatively low IOPS, relatively low throughput, kind of lightweight, and in some ways they didn't scale like we wanted to. Now, VDI does scale because they're discrete workloads. But when we started to look at, for example, the issue of the monster VM, we had some challenges we had to overcome. Today, though, we're seeing some of those challenges being overcome with solutions by companies like DataCore here. And we'll talk a little bit about one of the products that they bring to bear that is pretty incredible when it comes to helping you solve the need for high IOPS, monster virtual machines, and easier scale and high throughput as well. The real challenge in any environment, though, revolves around bottlenecks. And the results of an I/O bottleneck, which we've seen them all over the place. We've often said, okay, we have to move from 1 gig Ethernet for iSCSI to 10 gig Ethernet because we have to solve that bottleneck. We have to move from hard drives to flash drives. We have to solve that bottleneck. But there's other places in the application stack where there's bottlenecks as well, which means we can't maximize resource utilization. We end up putting these filters, almost these filters in place that, or funnels that we have to basically put all this data into and then get just a little bit out. So we have to order it all very, very nicely. And this makes it very difficult to maximize workload density This is why we still see nodes, even in the world of some hyperconverged solutions, that can't maximize their potential. We still see lots of resources potentially being wasted, but it's probably too strong a word. But we don't want to waste those resources. And as we want to be able to grow this, means we have to add more nodes to support those workloads, even though we're not pushing all of those nodes to their greatest potential. We're holding back workloads that could otherwise go further if we didn't have these bottlenecks to deal with. And that's really critical. But before we move on, we have another poll question we'd like to ask. And this one revolves around why you would choose hyperconverged infrastructure. So if you're looking at a hyperconverged solution, what are up to the top 3 criteria you have for choosing a product? And please just choose 1, 2, or 3 options here to help us better understand when you look at hyperconverged, what's the primary driver? Is it a technical one like performance and availability or flexibility? Or is it a more financial one like directly financial or even ease of management, which can sometimes be considered a financial sort of proxy? Sushant, when you talk to customers, what are their key drivers around choosing a hyperconverged solution?
It's interesting. It kind of varies. I would say one of the things that drives choices early is flexibility. How flexible do companies need their deployment? If, for example, we were talking to a customer who was in the military, who was doing essentially remote sites. This data center was going to be loaded on a truck and they wanted to go solid state. So they had a requirement to really specify out the hardware that they're going to run. So they were looking at solutions that were primarily software. So they needed that flexibility because they needed to be able to specify everything. Others, right, depending on the application, maybe looking at something like performance, because if you're looking at applications that need to scale out these monster VMs, you really need to make sure that you're getting that efficiency per node and that you can drive really large workloads, large VMs on, kind of highly dense nodes. That may be another consideration. Another thing that may come out is availability. Now, a lot of people talk about availability as, kind of, oh, well, I have multiple nodes all in the same cluster. One goes down, I can pick it up. But the area where this comes up is metro clusters, right? If you want to run a campus cluster and want to make sure that you have a few nodes running in different buildings to make sure you have different fault zones, then the ability to go beyond just kind of a local cluster to a metro cluster, that should start becoming pretty important to be able to say, hey, if my building goes down, can I still have other nodes available in different fault zones so that they can continue to run the applications that are vital to my organization?
Sushant, I just put the results up on the screen. The key driver that people are looking at, the top 2 are around performance and cost.
Yep.
I was actually surprised to not see financial win. That's what I've typically seen. So people are starting to look beyond the raw dollars, which is great, and looking at what the underlying infrastructure can actually do for them. So this is pretty good news.
Yep.
And moving on. So when we start looking at solving some of the bottlenecks that I just talked about, one of the first things you're going to hear is we should just go all flash. We should just adopt an all flash configuration, rip out every hard drive in our data center, and then replace it with SSD. And we all know that that's easier said than done for a number of reasons. If we look at the cost, these were costs that I actually found as I was putting together this report for DataCore. And again, it's going to vary depending on what you buy. But a 4 terabyte enterprise hard drive, you can get for $150. A 4 terabyte SSD that you want for anything that's reasonable for the data center, you're looking at potentially $1,500. That's a 10x cost differential. And a lot of organizations, I would venture to say most organizations, probably can't rip out their data center storage and replace it with something that's 10 times more expensive. Now, there are ways that organizations, like vendors, I should say, can go about reducing the overall cost of storage through things like deduplication and compression, but that still doesn't fully close that cost delta. Now, obviously, you get a massive performance increase, and you have to weigh the pros and cons on if the performance increase is necessary and worth it for the potential additional cost. And again, this cost differential won't be quite as great once you take data reduction techniques into into consideration. But it's still important to understand that it will be more expensive. But the other thing is the media type is often not the problem. You know, one of the reasons why we still see things like hybrid storage solutions and hyperconverged solutions being so popular is hard drives still have a place in the data center. We see lots of articles about saying things like, you know, disks are dead. Nothing can be further from the truth. We still see lots of innovation coming from hard drive manufacturers with, you know, capacity increases that are incredible. And from a capacity perspective, you're not going to beat hard drives for the foreseeable future. And don't forget, storage takes data only as quickly as it's received from the CPU or from the host. So if you've got bottlenecks that are not on the storage device, but in some other place in the system, you have to figure out ways to clear those bottlenecks in order before you can actually get all the benefit you would expect to see, even if you do go all flash. So nothing would be worse than going all flash and seeing a modest performance increase because there was something else that you didn't understand in the environment. And this still doesn't necessarily address the monster VM issue. We still have to figure out ways that we can make sure we can grow those VMs in a way so we can run quite large and demanding workloads. Another thing we can consider is scaling up. Now, one of the really great things about companies like DataCore and their approach to hyperconvergence, it's a software-based approach, and which means you can build nodes that meet your specifications. When you look at some hardware-based solutions, you're really limited in what you can do with the hardware, which makes scaling up sometimes prohibitively expensive. So you can basically make other size nodes with more resources. For example, you can make these huge nodes that have lots of RAM, you know, lots of SSD, lots of spinning disks, and you can really tailor them to meet the needs of your workloads. And over time, as your needs dictate, you can actually expand these individual nodes to be larger. And this has lots of second-order benefits when it comes to cost. I mean, it can help you massively when it comes to licensing costs because you have fewer nodes. It can help you as far as how much hardware you have to manage and all that good stuff. When you look at some appliance-based approaches as well, if you decide to try to upgrade them on your own, you can start facing support and warranty issues. So you have to be careful about that and make sure that you understand what you're allowed to do and what you're not allowed to do. So these software-centric hyperconverged solutions really provide a very immediate way to be flexible with expansion that you don't always see in the world of hardware solutions. And when it comes right down to it, the critical metric we have to think about is latency. Nothing is a workload killer like latency. In fact, if you look at every other metric anywhere in the system, ultimately it all rolls up to latency. And latency is really what is the application experiencing, and more importantly, what is the user experiencing? You could look at all the metrics and they look great, but if the user is seeing a lag because of something, it's going to be a problem no matter how well the system is supposedly running. So IOPS, throughput, if you're on spinning disk, your seek time, your CPU ready metrics in virtual machines that have multiple virtual CPUs and things like that. All of this ultimately rolls up to latency. And that's what we're trying to solve here, is we're trying to reduce the latency as much as possible in these solutions so that we can translate that into better performing workloads, and we can translate that into better overall utilization of the underlying hardware. And the results of poor latency are pretty significant. So your applications can be negatively impacted. Your costs are increased because you may be throwing hardware at a problem that is actually solvable via software, and your complexity goes up. As you're adding more hardware, it necessarily gets more complex to manage all of this stuff. Now I'm going to give you a quick primer on DataCore and sort of this idea of parallel I/O, but Sushant will be talking more about this later on in his presentation. DataCore helps you in some key ways solve some of the challenges that we see. And the way it does this is by not bottlenecking things, basically. So if you want to send data down to the storage device in the node, you can do so via multiple channels rather than this one queue that we used to see in the past. And by doing that, we're able to write data far more quickly and get far more performance out of the overall solution. And while we have the next slide up for a poll question, Sushant, let's talk about that a little bit more. Can you help us better understand exactly, actually, before we do that, we also want to ask you top 3 concerns around hyperconvergence. When you think about hyperconvergence infrastructure, what are the top 3 things when you think about it, you go, I'm not so sure about that. And Sushant, let's quickly talk about, I know you're going to talk more about this later, but let's give the quick primer on parallel I/O and sort of the underlying how it works to help people understand what bottlenecks it's addressing.
Sure. So one of the things that our engineering and team figured out is that there's a tremendous differential between the amount of work the compute layer can do and the storage layer can do. And even adding all flash doesn't, or eating flash devices does not really address that. So we started looking at saying, how can we take IO and parallelizing it? And by doing that, leverage the compute layer to essentially address that key metric, which you brought up, which is latency. A lot of times people will say, oh, we've got all these great, we can have this high number of IOPS. But if you look at the latency associated with that kind of peak IOPS, you'll see that the latency has gone up. And part of the way they've done that is they've kind of extended their queue depths. And the kind of the magic of parallel IO is that it's able to deliver a tremendous number of IOPS, but also keep latency low. And the way we do it is by leveraging the kind of horsepower that's sitting there in the compute layer to turn it on to parallelize IO, enabling us to do read and write much faster than without it. This has been borne out by a number of different benchmarks. And this is kind of what we believe is, what you see in these benchmarks should be a guidepost, but obviously your mileage may vary. So we actually do recommend companies try it out. See if, do an A/B test, use DataCore, use your, pick your favorite vendor, and run it head-to-head against these same workloads and see what kind of latency metrics you get, and is that meeting your business needs?
So, I mean, to put it simply, basically, rather than going deep, you're going wide in some ways, with multiple queues rather than a single queue that you have to basically wait in line.
In some ways, yes, right? Basically, think of the multi-core systems that people have. Think of the utilization of those cores is probably pretty low. So we're able to essentially scale up to utilize those cores to essentially address the IO demands of the applications.
Let's take a look at our results. And not a lot of surprises here. There's concerns around the overall cost of hyperconverged, what that's going to mean. The ability to scale things independently, which actually, when you look at a solution like DataCore, Sushant, that's actually solved because you can basically build nodes however you like to a point, correct?
Exactly right. And I think this is, in some ways, the third and fourth are almost tying together, right? It's that flexibility to be able to grow as you need it. And I think one of the things that a lot of people forget with hyperconverged, and I've talked to people who've deployed it at trade shows, when they're looking around for a new solution, I say, oh, why are you looking around? What's wrong with your current deployment? They say, well, I didn't really realize at the beginning that, when I bought a hyperconverged appliance, that I'm basically stuck with, buying nodes to increase storage capacity, even though I have enough compute. And I think that's one of the challenges that some people sometimes don't realize it in the beginning of their journey. That's something that they have to kind of watch out. It's kind of like a pitfall.
Absolutely. All right, let's move on. And Sushant alluded to a couple of benchmarks. I'm going to share those with you here. And this is something that was done by the Storage Performance Council, which is an independent testing organization. And you can see, hold on for 1 second. You can see that when we look at latency, there's lots of different options out there for what kind of storage you can buy. DataCore did a pretty tremendous job when it comes to actually beating some really key players in the industry when it comes to overall latency at 0.22 milliseconds. And that's pretty incredible. And especially when you consider something like 4.83 milliseconds as a top end for that. Now I'll help you understand the numbers at the bottom shortly, because I want to go to the next slide because I actually have an explanation for that on the next slide. And when we look at the performance results, so one of the things Sushant mentioned was that DataCore is able to increase IOPS at the same time that they're reducing latency. And so in these same performance tests, when we look at the kind of IOPS that people were getting by the Storage Performance Council, you can see that DataCore actually blew the lid off things at over 1.2 million IOPS in the tested configuration. And along the bottom of the screen is something that's really key. And that's the cost per IOPS. When people look at storage, a lot of times we're looking at the dollars per gig and things like that. Well, as we've moved into a world where storage performance is just as critical, if not more critical than capacity, the cost for a transaction or an IO is just as important. And as you can see, coming in at 10 cents is a pretty incredible metric. Sushant, do you want to provide a little bit of color into these metrics a little bit?
Sure. I mean, so the interesting thing here is that what you're looking at, or what the audience is looking at, is a comparison of a DataCore hyperconverged solution, which, as you know, has the entire node, which is the same node that is providing the IO workload. It also has to handle the IO workload, right? Basically, they're just going from one node back to the same node in terms of it, right? That's how kind of what happens. The IO fabric is just within the nodes. With the other ones, what you're looking at are separate storage and separate servers. So what is happening there is you have a separate group of hardware that is producing the IO load. In this case, with the Storage Performance Council, it's a OLTP database that's producing the IO load. In the storage, all it has to worry about is handling those IO requests, reads, and write. And so what you see here on a kind of cost per IOP is, on one side, with DataCore, is the complete cost of everything, right? Because the nodes, the hyperconverged nodes, is everything. It's compute, it's storage, it's networking. On the other side, when you're looking at just storage, it doesn't even include the cost of the servers that were generating the IO load. So in some ways, this is actually even more kind of this is the all costs with the DataCore hyperconverged solution compared to the all-flash arrays on the right-hand side.
And one of the key things around hyperconverged infrastructure is its ability to grow at your own pace. So you can start with a hyperconverged solution with as few as 2 nodes, depending on the vendor. Sometimes it's 3, sometimes it's 4. But with some vendors like DataCore, it's as few as 2 nodes. And by being able to start with 2 nodes, it further reduces the cost of entry into the platform. And as your needs dictate, you can either add more nodes, or you can expand existing nodes with more hardware. So you can put more RAM in, you can put more storage in, because we always, you know which resources your particular workloads are going to consume first, and that's the beauty of this type of solution. And more importantly, as you look at a solution with parallel I/O, and the great part is you can actually reduce the number of nodes you need, and that's something we're going to kind of wrap up here before I turn it over to Sushant to talk about a really critical case study. So we're going to be far more efficient with DataCore solutions, for example, on individual nodes in the hyperconverged infrastructure cluster, because we're moving to this parallel I/O mechanism where we don't have a single I/O queue that's holding up other parts of the system. We also get the ease of resource expansion on each individual node. So that means we eliminate this issue of linear scale that it really is both a blessing and a curse. We can still scale linearly where workloads demand it, but we have the ability to scale resources on demand in each individual nodes as our workload needs dictate. And the result of all of this is a need for fewer overall nodes, because we can grow the nodes, and because we're using parallel I/O, we're going to also reduce complexity and our capital costs at the same time. And as a result of this, when we start to look at workloads that require a lot of I/O, we're going to start to get far better performance, and that includes databases and large VMs and large workloads. These are workloads that are going to benefit significantly from parallelized I/O, and even in a hyperconverged infrastructure scenario. And before I turn over to Sushant, we've got one more poll question for you, and that's the last one. And it's, when we think about the types of applications that you're concerned about running on hyperconverged infrastructure, what are you concerned about when it comes to performance? So if you were thinking about a database, does it concern you on hyperconverged to operate those in that type of environment? Tier 1 applications like an ERP, VDI, or an analytics application. And Sushant, what do you think it's going to win the day here?
I would probably say it's either going to be databases or big data analytics. I mean, those are the ones where there's tremendous amounts. I mean, they're kind of the top of the food chain when it comes to kind of applications that require tremendous performance. And so I'd be surprised if it's not one of those two that comes out. I mean, the more people realize that those are the ones. Well, I guess I was right halfway.
Yeah, absolutely, by a lot too. So there's definitely some concerns from people around database performance in a hyperconverged solution. So this is definitely an apropos topic. And with that, Sushant, I'm going to turn it over to you. Let me give you control of the.
All right. So it looks I should have control. Let's see if I can move the slides. So everyone. Okay.
There you go.
Okay. I'm moving my mouse, but it doesn't seem to be moving yours. I think there it goes. So, oops.
There you go. Just click. You'll be okay.
All right, got it. So hello, everyone. We're going to do a little case study on emergency communications in Southern Oregon. So they're located in Jackson County on the Southern Oregon border. They've got an estimated population of 200,000 over a large area. They receive over, as you can tell, they're a 911 call center. They receive over 300,000 calls a year. They got 40 dispatchers. And they work with 30 agencies covering fire, law enforcement, and emergency medical. Now, kind of move forward. So their key challenge, SQL Server performance. They had a mission critical application, which was a dispatch application built on SQL Server. Essentially, they enter in the 911 call details. The application queries databases, other databases to access call and case histories. It finds the closest unit to send for help using GPS. And as you can imagine, over, since they got such a large territory, picking the right agency, which has a unit close to the call, is extremely important. The challenge that they were having was that the application can't keep up with a dispatcher, right? The dispatcher would have to wait for queries or commands to finish. So you can imagine, I mean, as the way that the customer talked to me about it, is when they call 911, it's probably one of the worst days in the life of the person calling. And to be told, oh, can you hold on, my application, hold on, it's, it's really hard for someone on their worst day to be told that, right? It's one thing when you call a call center and they say, oh, hold on, my application's running slow, and you're trying to talk about your credit card. And while it's important, it's not life-threatening. And what they really wanted to do was figure out why is the application running so slow. Did a root cause analysis, and they showed that the bottleneck was storage, right? Multiple times per day, their latencies were hitting over 200 milliseconds. So they said, we really wanted to address that. So they started looking around for solutions. Now, they also had other challenges. They wanted better availability, right? So they had a RPO goal of 0, so no data loss. They basically wanted to synchronize, replicate to their DR site. Oftentimes, what they would find is, in the event of a power outage or something like that, they could, the current scheme had them losing anywhere from 15 minutes to hours of data. So that was really concerning for them. They also wanted an RT goal of 30 minutes, right? So in case anything happened and their infrastructure at their primary site went down, they have to revert back to paper and pencil. And you can think about 30 minutes is their goal. And if you call 911 and they're down, boy, that's a really tough situation to be in when the people you need help from are down. So, they understood that 30 minutes is a long time, but they felt that, given the budgets that they had, that was the best they could do. They also wanted to be able to view motion to their DR site when needed, right? So if they had planned maintenance, they wanted to basically move their applications to their DR site so they can continue to run. And lastly, they wanted to test failover and failback. So being a government agency, they also needed to watch their costs. They had an existing NetApp storage that was only a year and a half old, and they want to say, okay, how do we still maintain value from it? They needed new hosts with additional compute and memory, so they knew that they already had budget for that. And they wanted a single pane of glass for management, right, to simplify management. So interestingly enough, when they first, actually, let me get to that in a second. So let me give you a view of that dispatch application. So the call taker inputs information to the database, right? This is what they call create to entry. Someone calls, the dispatcher will then put it into the application itself. A call summary is sent to the responder's phone. So you can imagine that the application has processed the data, figured out which are the units that are closest, which are the units that are required, and sent it to the responder's phone. the details are sent to the responder's laptop. So, the summary comes on the phone, more details are sent to the laptops, and the dispatcher receives prior and premise information, right? So for example, they may want to know that, hey, this location is next to a chemical factory. Well, that would be pretty important if there's a fire going on. Or there's been, for example, domestic violence incidents at this location at the past. So this is all information that is needed for these emergency responders to be able to do their jobs. So here are some of the goals that they had in terms of creation to enter as well as entry to dispatch. And you can see you're really talking about, essentially 1.5 minutes to about 2 minutes most of the time, right? 95%. So when their dispatchers are not able to enter in the information because the application was running too slow, they're not meeting their metrics in terms of, kind of the goals that they're trying to do. And so that was a bit of a challenge for them to be able to say, how do we, speed this up? Because they had, as an organization, had these goals. And quite honestly, when they talked to me about this, I was like, wow, this is great. I'm glad as a citizen that, 911 call centers have these goals of being able to get this call to entry and entry to dispatch, and that they actively, work to make these metrics. So let's talk a little bit about what their infrastructure looked like. So they had a primary site and a secondary site, and they had virtualized infrastructure. So they had one host at the primary and one at the secondary, and they're basically running about 25 VMs, standard business applications, Active Directory, Exchange, right? That was fine. They had physical servers as well, because their SQL Server was not virtualized due to inadequate storage performance. They had tried, they said, to do this, and they found, nope, couldn't do it. Performance was just way too slow. So they had kept their SQL Server running on physical servers, and the SQL Server hosts were clustered. So they had that going for them. The storage was a NetApp FAS at both the primary and the secondary. They had a scheduled synchronization job periodically depending on the importance of the data. For critical data, the job ran every. But most data was 12 hours old. So you can see that the synchronization job, while it was trying to keep their critical data up to date, most of the data was actually, 12 hours old. Some of the data could be, for example, license plate lookup, right? A police officer stops a car. One of the things that they do is they put in the license plate and see if there's any additional information about that car based off the license plate. So if this would be some of the what they consider non-critical data. Now you can imagine if you're a police officer, you would consider that critical data. So they actually looked at some alternatives. They said, okay, what about you looking at acceleration software? So at that time, Pernix Data still existed. There was Infinio, and they found it wasn't enough performance. And it didn't address availability. They looked at the VMware vSAN software. They found it expensive. It was incompatible with their existing hardware. So they said, okay, that's not going to quite work. They looked at Zerto, but Zerto provided them availability but didn't address performance. And said, okay, well, those are kind of the software-based approaches. What about if we change out the hardware? So they looked at new storage arrays. They looked at NetApp, Pure, Nimble, and they felt like they were going to get a decent performance increase, but not enough to really solve their problem. So, interestingly enough, they weren't actually looking at hyperconverged when they started talking to DataCore, and we, in kind of understanding what they wanted to do, said, you've got a, kind of a small to medium-sized data center. What about hyperconverge and consolidating down your infrastructure while getting better performance? And they said, all right, let's talk about this a little bit more. So they, since performance was so important, they they came up with a way to actually test performance. They used Diameter, and they said, okay, here's what we'll do. We'll do it in different block sizes from 2K, 4K, 8K, all the way up to 256K. They will do, and they'll do it random versus sequential and read versus write. So they did 28 total runs where they said, okay, we'll take the smallest block size, 2K, we'll make it random and do read. Then we'll do 2K, random, write. Then we'll do 4K, right? And so they keep on going down this list, and they did basically every permutation. So they had about 28 runs. They used the same VM in testing, but the hardware was different. So NetApp had separate servers and storage. The DataCore Hyperconverge had combined servers and storage, right? So the same node, as I mentioned earlier, that would be generating the workload, the I/O workload, had to handle that I/O as well. So they tested it, and this is what they found, right? They looked at both IOPS and throughput. So in terms of IOPS, they saw a 421% increase on average compared to their existing infrastructure. In terms of the median, because again, there were 28 different runs, they saw basically a 13x improvement in terms of IOPS. For throughput, they saw basically a 700% increase on average, but in the median case, they saw about 400% increase. So again, they're seeing the performance increase compared to their existing environment that would make them say, okay, this is exactly what we need in terms of the performance increase that we're looking for. Now, let me move on to the next slide. There we go. So they had the quantitative, and then they also looked at quantitative. So the key metric that Scott mentioned earlier was latency, right? And they tried to simulate that latency in their test lab, and they couldn't do it. So to a certain extent, they kind of had to take a little bit of a leap of faith. They saw that the lab results were great, but they said, okay, let's see what happens in production. And they were actually pretty pleased by what they saw in production. So in production, they saw a 20x improvement in latency on average. And when you look at peak, right, so the peak latency I mentioned earlier was about 200 milliseconds, and it was hit multiple times per day. The current peak is less than 5 milliseconds, so that's kind of a 40x improvement. In the lab, I mentioned that they saw, anywhere from 4 to 14x performance increase in IOPS and throughput, and in some of the cases, in some of the runs, they actually saw 100x improvement. So from a kind of a numbers perspective, latency, IOPS, throughput, pretty happy. But if you recall, right, this kind of started not because they had seen performance issues, in terms of their kind of monitoring tools. It's because the dispatchers were complaining. So that was also important, right? So they also wanted to look at qualitatively, are the dispatchers happy, right? Or, what's it like anecdotally? And to their pleasant surprise, the dispatchers no longer complain about the input lag. The application keeps up with what they need to do. And so there's no danger of having a dispatcher having to tell someone who calls 911, hey, hold on, wait a second, I'm still waiting for my application update. They're able to vMotion their virtual machines to secondary site for maintenance, and the users are unaware that they're no longer running on the primary site. And I'll talk about that in a second. But let's talk about what their infrastructure looks like now. So now what they have is the number of hosts dropped. So the SQL Server instances were virtualized. That means that they went from 5 total servers, 2 virtual and 3 physical, down to 2 virtualized hosts at their primary site. At their secondary site, they went from 3 total servers, which was 1 virtualized host plus 2 physical, down to 1 virtualized host, right? So all their applications are now virtualized. The storage is now available through the DataCore Hyperconverged Virtual SAN. So they have 1 per host with direct attached storage. The data is synchronously mirrored to the DR site. So 911 calls, radio traffic, critical SQL Server data are using CDP, continuous data protection. So they're able to keep track of all the changes to that data. And the NetApp storage became tier 3. So it's now their archive storage. So they're able to still get value from that as well. Let me talk a little bit about the availability and flexibility benefits as well. So in terms of availability, with the synchronous replication between hosts, their RPO is now down to 0. There's no loss of data because if a node goes down, that data is synchronously replicated. So there is no way to lose data. And the RTO is basically the time to restart the virtual machines, right? So you can imagine that if their primary site went down because it's synchronously replicated, all they have to do is restart the virtual machines at their secondary site, and they're back up and running. So they're very pleased from an RPO and RTO perspective. In terms of flexibility, they were able to add memory to increase their cache size. They're looking to add NVMe to their storage tier, and their SQL servers are now virtualized. So that flexibility of that you get from having hyperconverged software versus kind of an all-in-one appliance where you're limited in terms of being able to change things out, they're pretty pleased. It gives them more flexibility. Not only do they get the flexibility to do what's needed, they can now meet their needs a little bit better. So what I mentioned earlier about costs. So what they saw is that they're able to reduce their infrastructure. So they have about 60% less infrastructure now. They're able to reduce their hosts from 8 separate hosts down to 3. They limited the external storage for production data. And so now they save on administration time and also power, cooling, space efficiency. So that was kind of a nice benefit to them to be able to, have a highly dense, smaller footprint environment, both at their primary data center and their DR site. But here's where this was an unexpected benefit that they didn't even realize as they started going through it, but it's turned out to be kind of the key win for them. So aside from being able to have a faster SQL server, aside from the kind of availability benefits and just reduction in infrastructure, they're also able to serve on their SQL Server licensing costs. So and they were able to save roughly about $100,000. So obviously the first question is, okay, how'd you do that? So what happened is that Microsoft was changing to a per core licensing, and it was going to cost them about $120,000 with their physical hosts. So each physical host was a single processor with 12 cores. So they had 5 servers, right? 3 at their primary site, 2 at their DR site. Each server had 12 cores. Okay, so that's going to cost them a fair amount. By virtualizing SQL Server, which they were able to do with the DataCore Hyperconverged SAN and the performance that came with it, they're able to better control the number of cores. So now they have 1 virtual machine with 8 virtual CPUs, right? That's the equivalent of cores, and 2 VMs with 4 virtual CPU cores. So now it's a total of 16 virtual CPUs or cores. They also were able to consolidate the number of instances. So previously I talked about they had 5 physical instances. Now they've dropped it down to 3 virtual machines. So when you look into the reduction in the total number of instances going from 5 to 3, as well as the reduction in the number of cores they're actually using from 60 down to about 16, their license cost afterwards was about $25,000, right? So maybe I exaggerated. Maybe they saved $95,000, right? But generally, this move to getting better performance, being able to virtualize their SQL Server, and be able to better control the number of cores and the number of instances was kind of a huge win for them. So let me talk a little bit. I mentioned earlier about availability, and let me explain to you kind of one of the situations that came up for them and how they were able to leverage the better availability. So their UPS at their primary site was to be replaced, and it would knock out power for 6 to 10 hours, right? That's a pretty long time. So what they wanted to do was vMotion all of their VMs to the secondary site. So they did that. It took about 10 minutes to do that. Now the interesting thing is, because of the performance that they were getting from the DataCore Hyperconverged Virtual SAN, their users not only were able to continue accessing the applications, there was no performance degradation. It was completely transparent to them. So yes, the users knew that the primary site was down, and they knew that something had changed. But for the dispatchers, there was no difference in terms of their speed of being able to access their applications. They didn't have to say, they didn't have to revert back to paper or pencil or anything like that. They were able to continue doing their work, which they were doing, right? And again, right, this is a situation where the calls that they're getting, they are life and death, right? Oftentimes people talk about their applications as being, the performance of those applications is life and death. Okay, 911 call center, yeah, that actually is life and death. So once the UPS was replaced, all their virtual machines were vMotion back to the primary site. They basically started at midnight and were back to their primary by 9 a.m. So the other good thing is storage is no longer a single point of failure, right? When they had their before infrastructure, the NetApp that they were using for their kind of non-SQL applications, that was a single point of failure. Now again, it was synchronized, they had jobs running, But again, there was 15 minutes of for the critical data, and it could be 12, and it was 12 hours for the non-critical data. So they've been able to dramatically improve their performance and their availability while decreasing their costs. So I know we're kind of running out of time, so let me just take about 5 minutes to give you a little background on the DataCore Hyperconverged Virtual SAN. So one of the things that's pretty important to keep in mind is that when you're looking at the use cases that you want to look at for, you really have to think about the kind of performance requirements of your applications. So what we've seen in the past, and we talked to a number of customers, is they've been using Hyperconverged just fine for VDI and remote sites. So these lightly loaded applications, right? Now, for those environments, a VDI environment, you could typically require 200,000 IOPS. But when you go to databases and other tier 1 workloads, right, there's much more IO performance required and low latency. You could be talking about 1 million IOPS or more, and the key metric is obviously latency. So one of the things I want to point out is there's been kind of a gap in terms of the work being able to be done by the compute tier and then storage. And the amount of work, it used to be they went pretty much hand in hand, and that's because the driver was really clock speeds. But about kind of the late 2000s, the CPU guys, especially Intel, went toward a multi-core architecture as a way of delivering more work potential. So you're seeing not only these multi-processor systems, but more cores per socket. And what that's created is that there's an IO gap in terms of the amount of work being able to be done by the compute tier and what you can see from storage. So the way DataCore has addressed this is we looked at parallel IO. I'm going to skip over some of these slides. So they talk about some of the things that Scott has mentioned before, but essentially we looked at saying, okay, if we really believe in this parallel IO technology, we need to be able to prove it. So we looked at the SBC performance benchmark. It's industry standard. It's independently verified and audited. You can see it. Go onto their site. You can see results from HP Enterprise for their 3-part systems. You can see it from EMC, Dell, NetApp, all the major vendors are there. And we really wanted to say, okay, how can we show that this hyperconverged system running this parallel IO is able to deliver the performance that people need? So Scott talked a little bit earlier about the performance from an IOPS perspective, the price performance at 10 cents per SBC1 IOPS, and also the response time of 0.22 milliseconds. He showed you this graph earlier, but let me move forward and talk a little bit about how DataCore is able to do it and kind of give you a visual representation of parallel IO. And actually, I pause for a second. Some questions we often get when I'm doing it in front of an audience is they often ask us about Nutanix. Nutanix is kind of pretty well known in terms of is one of the kind of key vendors in the hyperconverged space. Interestingly enough, when you look at the reference architectures from Nutanix, there really aren't many performance numbers, especially when it comes to databases and tier 1 workloads. You'll see the numbers for VDI, but not necessarily for kind of the key applications. So we kind of did some digging around, and it turns out one of their technical solution architects was running some benchmarks. And so this is kind of an example of something he published onto Twitter. He's got a Nutanix cluster running 116 VMs at 342,000 IOPS. You can see he's got 16 hosts. The top right, you can see he's got latency of 1.36 milliseconds. Okay, so we said, all right, well, here's a kind of something that he did. Let's see what we can do. One of the questions people ask us is, wait, why are you looking at something on Twitter? Why don't you have kind of published results? And you can see that people in press and analysts have tried to benchmark Nutanix, and they've been prevented. You can read the articles yourselves, but essentially there aren't really published third-party reviews of Nutanix performance. So we kind of did the same test that Josh did, and we ran a number of VMs that was running about 4,400 IOPS per VM. And you can see that on 2 nodes, we're able to hit 263,000 IOPS. On 3 nodes, we hit about 400,000 IOPS, which is roughly what he saw on 16 nodes. So if we were able to kind of scale it up to 16 nodes, we'd be about 2.1 million. So we're also able to make a huge difference when it comes to being able to run all the nodes in, or run all the VMs in the event of a failure, right? So one of the challenges that you may have when you talk to vendors about, the number of nodes that you see is, okay, how many nodes do you really need? With better performance per node, you actually need fewer nodes. What you really want to do is think about it from an n+1 to an n perspective. So if you have n+1 nodes, one goes away, can you still run all your workloads on the remaining n nodes? And with DataCore, the answer is yes. So that means you're really able to maximize the amount of kind of density, VM density that you have on your nodes. So I know that we're running out of time. So let me kind of just give you a brief summary of DataCore for those of you who aren't so familiar with it. And then I guess we can take some questions. So give me a second as I kind of flip through some of these slides to cover the summary. So for those of you who are not familiar with DataCore, we've got about 30,000 deployments worldwide, 10,000 customers, 10th generation product. We cover both software-defined storage and hyperconverge. We're software, so that means that you have the flexibility to pick and choose the hardware that you're familiar with and comfortable with. And we got offices around the world. So with that, let me ask Scott to see if we have time for some questions and any remaining housekeeping.
We do. We have time for one or two questions here. The question we have here is, when we talk about I think he's referring to the SPC1 numbers, what was the general configuration of those nodes, the combination of SSD and HDD?
Good question. So there was the DataCore nodes, I want to say was roughly about 10 to 20% flash. The rest was spinning disk. If you actually go onto the SPC console, you can see actually the full configuration. Not only can you see it for DataCore, but you can see it for any vendor that has submitted the SPC benchmark. They actually have to specify the full configuration in their summary, or actually in their report. So you can actually see the full configuration, not only for DataCore, but the all-flash array vendors, any kind of storage system that was submitted, all of that information is available.
And we'll ask this last question, then we'll wrap up. We'll do a prize and move on. And the question is, can the DataCore solution handle holographic color presence for collaboration as well as shared and highly detailed 3D imaging?
That's a good question. I don't know the kind of performance metrics for that type of application. My sense is that we probably can, given how well we do in terms of IOPS throughput and latency. But different applications have kind of different ways to stress the system. So my recommendation is, give us a call. We can talk you through, better understand your application and see if there's a configuration that best matches your need. I'd be surprised, given the kind of results the numbers we've been able to put up on the board, if we couldn't address it. But again, right, I think our solution architect would have to understand your application a little bit more and understand the metrics you'd like to do.
Excellent. And we have another, the question is, what's the link for the benchmark result? It just basically do SPC-1 DataCore search in Google, right?
Yeah, or you type in Storage Performance Council, and then they have a couple of different ones. The metrics that the benchmark we did was SPC-1. So just type into Google Storage Performance Council. When you get to their site, look for SPC-1, and it shows you their kind of top 10 in terms of IOPS as well as cost per IOPS, and then you can also see latency as well.
Great. And we're going to choose a winner for a $300 Amazon gift card. Oh, before we go though, make sure that you schedule a demo if you want to try this out too. So there's a link on your screen, info.datacore.com/live-demo, and also a trial of the DataCore Hyperconvergence virtual stand. There's a link on your screen there. Take a quick screen capture. And while you do that, we have to choose a winner for the Amazon gift card. And today's winner is going to be Jay Dibble. We'll be reaching out to you after the event, Jay, with information about how to get your Amazon gift card. Thank you, Sushant, for being here with us today. Really appreciate it.
Thank you for having us.
And thank you to our audience for joining us for today's event. Have a great rest of your week.